So tonight's homework is going to review what we worked on in class today about comparing fractions and thinking about size. So in problem 1, you have equal parts. So we want to remind students that fractions are the numerators the part have in the problem, and then the whole is what makes up 1. So one of the big ideas that we learned today is that if we have the greater the number in the whole, so the greater the whole, the smaller the part. So what that means is we use the example today if we had a birthday cake and we had fifths, and we knew every person was going to get 1. If we had fifths, the cake is cut into 5 equal-sized pieces. Well, if we invite more people over to the party and say we have to cut that same cake into 10 equal parts, the pieces become smaller. So as we get more pieces in our whole, the pieces become smaller, the part that we see. So the 1, in this case, third, or 1/6, you want your student to think about which is larger. The other way to support this understanding is to think about drawing a tape diagram. You could have your student draw a tape diagram next to this, cut 1 into thirds, and then cut 1 into 6. And you can see how much smaller the parts are when we're into sixth. So the rule here is that the larger the whole, the smaller the part. So that should be able to help your student with problem 1. For problem 2, we're going to do that same work, but instead of seeing the name of fractions, we're going to be seeing the number. So again, students can use their tape diagram, which you see is given here as an example. They can use a number line that also works to explain this work. So it's the same concept. The larger we see the denominator, the smaller that piece is. So of 3 pieces, is 3 out of 6 bigger or smaller than 3 out of 7? And in this case, we know that 3/6 is greater because 6 are bigger pieces. So students are going to use that thinking on A, C, and then on D, it gets a little trickier because you can see here we don't have a like numerator or a like denominator. Traditionally, people are told to change the denominator, changing these two so they're equivalent so we can compare them. But today we learned that if we know the piece or the numerator, we can then compare those as well. So in this case, 5/7, we can turn that 5 into a 10 by simply multiplying by 2. So we know that to multiply or make an equivalent fraction, we need to multiply by the same numerator and denominator because that's equivalent to 1. And in this case, we would get 14/10. So again, students would use the same strategy they used in C and A to say, I have 10. Do I want 10/14? What size are those pieces compared to 10/13? As you go on here, the tape diagrams are going to be helpful here. And then in this case, in question 2, we were changing the numerator. Here, we're going to change the denominator. So we should always make the smaller denominator into the larger. So here, 3/4, we can change fourths into 12ths. So students are going to have to think about what we multiplied here, do the same thing, so we have an equivalent fraction. You're going to change fourths into eighths so that you can compare those two fractions. The difference here, the thing that was hard for students in class, was now we have the same size pieces. So if we have the same size pieces, it's the numerator that's greater is the greater fraction when we have the same denominator. So what this is saying is when we have equal pieces, the number that we have more of, or the greater number, is going to be the larger fraction. Here you can leave the 1, the mixed number, and leave the whole number alone. Change fifths into tenths. So those rules will kind of help you and your student work through these problems. So when we're looking at the same denominator, it's the larger part that would be the greater fraction. All right, and then on the back of the sheet, drawing a number line to compare the fractions. Students can either use a separate sheet of paper or, again, they can choose to do it right here. It's going to get a little crowded, though, on one number line. So if comparing 3/4 to 8ths, your student can draw a number line or just create an equivalent fraction. Turn fourths again into eighths. Here, turning fifths into tenths. So the students can use a number line, or they can just use the mathematical practice of making an equivalent fraction. Make fourths into twelfths and make thirds into ninths. Once they do that, they'll have the same denominator in their problems, and then they'll just be able to compare. And then here, when we're comparing the fractions, drawing a model if choose, this is just the same practice. They're going to have to make a decision, though. Do I want to change the denominator in this case or the numerators? So I would say in the problems that I circle, which is probably going to be most of them, they're going to want to change the denominator. But in these two, over here in pink, I would change, you don't even need to make a change in this one. This one you're just comparing numerators and thinking about the size of the part. Here you may want to make this into a mixed number. You may want to use a number line thinking about what those are. And then the last one is the big idea, and for kids being able to explain that. 4/9 is greater than 1/3. Ted thinks 4/9 is less than 1/3. Who's correct? So again, using that strategy to make these two fractions comparable. Students can use a diagram, they can use a number line, or they can just show mathematically with equivalent fractions.